Hello, good day, dear colleagues. Здравствуйте, дорогие коллеги. У нас сегодня прямо чрезвычайно интересная, горячая дискуссия о том, куда будет двигаться в ближайшее время.
The fight with oncological diseases is going to move to, and we have a very interesting guest, and as long as the main discussion will be in English, I will also switch to English. So, dear Russian-speaking listeners, you can choose the translation channel and listen to us in Russian.
Very famous person, I would say, Professor Louis Cantley. That's the famous cell biologist and biochemist who has made significant advances in understanding of cancer metabolism and metabolic diseases as well. So among the most notable contributions are the discovery and study of the enzyme PI3 kinase, known to be important to understand cancer and diabetes disorders. And what we would like to discuss today, that's recent advances in cancer treatment, approval new guidelines updates, and approval of these new guidelines updates connected to insulin sensitivity and glucose fructose uptake, and it links to biohacking and healthy lifestyle trends, which is a bit of speculative issue. And I mean, it's very, even in Russia, it's kind of fashionable to have all these intermittent fasting diets, low-calorie diets, and some other approaches. And, it was a lot of rumors and discussion if it really helps. And may I start with a provocative question? Is it definitely helps, all these new type of diets like keto diets, intermittent fasting? And what is scientific approval of those type of specific way of actually filling up your organism with the energy? Professor?
Yes, so our research has really provided some insight as to why diets could be helpful in treating cancer with many types of drugs, but in particular with a family of drugs that recently developed to treat PI3K mutant cancers. So you mentioned my discovery of phosphatidylinositol 3 kinase, which we abbreviate PI3K, and that enzyme mediates everything insulin does. And it's very highly mutated in breast cancer, in endometrial cancer, in glioblastoma, in colorectal cancers. Many types of cancers have mutations in this gene. And what those mutations do is allow insulin to activate the enzyme much more readily. And that drives the cancer. So diets that can reduce insulin levels, we've shown at least in mouse models, and we're now doing clinical trials to try to validate this in humans, can also improve the effects of these drugs that inhibit PI3K. So we're testing this in endometrial cancer clinical trials, as well as breast cancer clinical trials, and even in lymphoma clinical trials, where PI3K inhibitors have already been approved. So that's, we're very excited that this specific dietary intervention can dramatically improve responses. Now, whether that dietary intervention might work even independent of a drug is maybe a little more speculative. But I would argue that, yes, it probably can. I can show a few slides if you would like that might provide a little background on why this is so.
Yes, please, sure.
I'm sorry, I can't hear you.
Yes, please, if you want to show some slides, you are warmly welcomed, but we cannot see the slides yet. Can you hear me, Professor? Hello?
I'm sorry, but I cannot hear you at this point.
Sorry, I cannot, colleagues, I cannot hear, the professor cannot hear me.
I can hear you now.
Oh, you can hear me now. Okay. Yes, please, go ahead with the slides. It's really interesting. But as soon as we have not only scientific auditorium here, so just maybe some explanation in the common language.
Sure. These slides will, I think, are designed for the layperson to understand. So hopefully, this slide is just my conflicts. I'm involved in a number of companies. I've started a number of companies, including a company that provides dietary intervention for cancer trials. So PI3K, as I mentioned, is an enzyme shown here in blue. And it carries out a catalytic reaction that we discovered in 1988. It produces a lipid that's in plasma membranes of cells. So this is the membrane that surrounds the outside of every cell in your body, has this lipid in it. And the lipid is facing the inside of the cell. And this enzyme puts a phosphate on that lipid and produces a lipid that had not, prior to our discovery, not known to exist. And it turns out that this lipid mediates everything that insulin does in your body. But if you make too much of the lipid, it can actually cause cancer. And there's not only does PI3K drive production of this lipid, but there's a tumor suppressor gene that was identified 10 years after we discovered PI3K, called P10, which is one of the most frequently deleted genes, tumor suppressor genes in human cancers. And it does the reverse of what PI3K does. It takes that phosphate back off of the lipid. So if either you lose P10 or you have an activating mutation in PI3K, you get more of this lipid, and that will drive cancer formation. What this lipid was designed to do, what it evolved to do, is to control glucose in every cell in your body in response to growth factors, hormones, and in particular, in response to insulin. So whenever you eat a carbohydrate-rich diet, particularly sugar, for example, that tells the pancreas to release insulin. Insulin activates PI3K in your muscle, in your liver, but also in other cells, including if you have a cancer, it can activate PI3K in the cancer. And this will cause these cells to grow or store fats, depending on what cell type it is, or taking glucose and store it as glycogen in muscle, for example. So all the control of the glucose in your body is mediated through this enzyme, PI3K. And of course, the P10 enzyme, which reverses what PI3K is, the brakes that puts it, that slows down this pathway and ultimately brings it back into control. So the problem with cancers is they have too much activation of PI3K. They take up much more glucose than normal cells, and they use it for growth. This is how cancer cells grow. And so that's why these mutations in PI3K drive cancers. So this is a little illustration of what should happen normally. If you eat some pasta, for example, or rice, or something which is pretty rich in carbohydrate, then that gets broken down in your intestine to glucose. Glucose goes into the bloodstream, ultimately makes its way to the pancreas, and that tells the pancreas to release insulin. The insulin then goes to muscle and liver, activates PI3K, makes this lipid that I discussed, and that turns on glucose influx into muscle, and it drives that glucose to be stored as glycogen. That brings the glucose back into homeostasis, so your glucose levels come back to normal again. So this is what should happen in healthy individuals. Every time you eat anything with carbohydrate in, insulin activates PI3K in muscle, brings everything back to homeostasis. If you happen to be insulin resistant, then that means that the muscle's not responding to insulin. And that's because there's an impairment in the ability to activate PI3K in the muscle. And therefore, the glucose can't get stored in the muscle, and the glucose levels are high in the bloodstream for a very long period of time. It'll ultimately come out in the urine. This is how diabetes is originally identified, insulin resistance, that the sugar is ending up in the urine because it can't be stored in the muscle. And that's the first indication that you have a problem with activating PI3K in the muscle. That means the glucose level goes up and the insulin level goes up much higher. So people with type 2 diabetes, insulin resistance or type 2 diabetes, the pancreas tries to make enough insulin to bring glucose back into control. But if it cannot, then this results in type 2 diabetes, at which point you need to take a drug to keep the glucose levels lower. And in some cases, the physician may recommend insulin injections to bring the glucose back in control. In America, probably more than 40% of adults over the age of 40 have some level of insulin resistance, if not type 2 diabetes. This is due to overeating, particularly sugary rich foods. So if you happen to have a tumor in your body, then the tumor uses insulin to drive its growth as well. And so this period of being insulin resistant can make your tumor grow faster as well. And there's very good evidence that patients who are insulin resistant have higher rates of death from cancer than patients who are not insulin resistant. So this link has been somewhat mysterious, but I think it can be explained by the fact that this high level of insulin will drive the growth of the tumor much more readily than if your insulin is at normal levels. Now, we've known for a long time that tumors take up glucose much more readily than normal tissues do. This was first discovered by a German scientist named Otto Warburg in 1923. He just took a tumor from a rat and compared it to other tissues in the rat, and the tumor was taking up glucose at about 50-fold higher rates. We call that the Warburg effect. It was our first insight that tumors have a different metabolism than normal tissue. We use this in the clinic today as a way of monitoring where a tumor is. If you inject a patient with a radioactive form of glucose and then follow where that goes by positron emission tomography or PET imaging, then this will visualize the tumor because the tumor is just taking up much more glucose than any other tissue in your body. Now, if we look at PI3 kinase, there are multiple types of PI3Ks in different tissues, but the one that's really important for insulin signaling is the one that's called PI3K alpha, or the gene is called PIK3CA. And that's the one that really is driving cancers. But there are, at least in solid tumors, I should say, breast cancers, endometrial cancers, glioblastomas. But there are also PI3Ks that drive lymphomas as well. The delta isoform, PI3K delta or PIK3CD, is in T cells and B cells. And this overactivation of this enzyme will cause the growth of lymphomas. So drugs are being developed not only to inhibit the PI3K alpha, the one on the far left here that mediates insulin signaling, but also the ones that mediate lymphoma growth, the delta isoform. And so at the bottom are the number of drugs that have already been approved, 3 different drugs that hit the delta isoform, capanelisib, idelalisib, duvelisib. These are all approved, but only one drug has been approved that specifically hits the alpha isoform, and that drug is called alpelisib. And this drug does extend life for women with PIK3CA mutant breast cancers, but it's not a home run for reasons of the complexity that when you inhibit this enzyme, you also raise insulin levels because you acutely turn off everything insulin does, and the pancreas has to make more insulin. And that feedback will reactivate PI3 kinase, limiting the effectiveness of the drug. So there have also been a number of drugs that failed in the clinic that I won't get into. So the question is, how can we make these drugs work better? This just gives you an example of a woman who has a PI3K mutant breast cancer that has metastasized to the liver. And you can see where these red arrows are pointing to the metastases in the liver. And this is an FDG PET. And you can see by the dark spots here that the liver metastases are taking up glucose dramatically more than any other tissue in the body. The kidneys and the bladder are just showing the exit of the drug from the bloodstream. But where it gets concentrated is in these metastases. So this tells us, yes, this PIK3CA mutant, the PI3K mutant tumor, has the ability to take up glucose at a dramatic rate. And this is what happens after putting the patient on this drug, alpelisib, that inhibits that enzyme. You can turn off the glucose uptake into the metastases. And as a consequence, this is benefiting the patient, extending life. But unfortunately, thus far, it hasn't really been curative. So this is one of the main things we're working on, is trying to figure out how to make these drugs work better. Now, if we ask, where do we see mutations in PI3 kinase or this other gene, P10, the tumor suppressor gene that reverses what PI3K does? These various colored bars indicate either in blue the loss of P10, or in green or red the activating mutation or amplification of PI3K. We can see glioblastoma, uterine cancers, prostate cancers, renal cancers, breast cancers, many of the cancers that cause death in America, and I'm sure Russia as well, have very frequent mutations in these two genes. In fact, glioblastoma, more than 90% have one of these two genes and either mutated, amplified, or deleted. So the problem then is, why can't we get cures with these drugs? Can we make them work better? And so we've used mouse studies to try to understand how to improve the effects of these drugs. And what we see in the mouse, not unexpectedly, is that when you give this drug, alpelisib, the one that inhibits PI3K alpha, blood glucose level goes up because you're turning off everything insulin does. So the mouse patient in this case, but we saw this in human trials as well, the blood glucose goes up dramatically when you give this drug within 20 minutes or so. And as a consequence, the insulin level in the bloodstream goes up. And the problem with that is that the high level of insulin will reactivate the PI3K, even in the presence of the drug that you're trying to kill the tumor with. And that is why these drugs, although beneficial, are not home runs. And the question is, by dietary intervention, can we make these drugs work better? And so what you see is that if you give a tumor insulin, this is ex vivo, so we have complete control. This is not inside the mouse, not inside humans. It's actually the tumor growing outside in a plastic dish. And we give the tumor insulin, and it will protect it from this drug, alpelisib. So that high level of insulin in the bloodstream of the patient is helping keep the tumor alive, in spite of the fact that we're trying to kill it with the PI3K inhibitor. So how can we keep the insulin level down so that we don't get this feedback that brings the tumor back to life? So we need to use drugs that lower not only serum glucose, but also lower serum insulin. Obviously, we don't want to give the patients insulin. We can give them metformin, a very commonly used drug. I'm sure that many patients in the audience, or many people in the audience, have taken metformin to control their glucose levels. But there are better drugs than metformin. It's a very safe drug. But there are sodium glucose cotransporter inhibitors that block reuptake of glucose in the kidney. So the glucose ends up in the urine, and that can lower serum glucose, but also will lower serum insulin. But there are also diets that will lower serum insulin, including the so-called ketogenic diet, which is only 8% carbohydrate. So there's so little carbohydrate in the diet that the pancreas doesn't receive this elevation in glucose in the blood, and therefore does not release as much insulin. Most of the diet is fat. So we've tried both of these effects in mice, and they both turn out to be very effective at using sodium glucose cotransporter inhibitors or ketogenic diets. at keeping blood glucose levels low, but also importantly, on the bottom right here, keeping insulin levels low in the presence of the alpelisib drug. And so what's happening then is, as I showed you earlier, you eat diets that are high in carbohydrate, your insulin levels go up, that activates PI3 kinase in the tumor and keeps it alive, keeps the tumor alive, in spite of the fact that we're trying to inhibit PI3K, the insulin is overriding the effect of the drug. So if we give the drug then in the presence of a ketogenic diet, we can now dramatically suppress the growth. In fact, we can shrink the tumors to essentially nothing compared to the PI3K inhibitor alone, where we somewhat slow down the tumor, but we don't kill it. But if we impose a diet that keeps the insulin low, now the drug is very effective. So as a consequence, then, we have started a number of clinical trials at Weill Cornell and our sister institution, Sloan Kettering, as well as Columbia University. All three of these institutions together, we are working together to conduct clinical trials with approved PI3 kinase inhibitors, the drug I mentioned, alpelisib, in combination with ketogenic diets to try to keep the insulin low enough that we get a better effect. My collaborator in this, my former trainee, Marcus Goncalves, who's an MD, PhD endocrinologist at Weill Cornell, assistant professor at this point, has played a major role in designing these trials. He treats patients who have diabetes, so he knows well how to control glucose and insulin levels. And working together with the oncologists at Weill Cornell, Sloan Kettering, and Columbia, we've designed trials to test this idea that works so effectively in mice, in human patients. And so in summary, PI3 kinase mutations are driving glucose into tumors, and this is causing the tumor growth. That's due to mutations in PI3 kinase that enhance the ability of insulin to drive glucose into the tumor. Many solid tumors have these mutations, and we think we can benefit a very large fraction of patients, including pancreatic cancer patients. Even though they don't often have mutations, they have very high levels of insulin in the pancreas, and keeping insulin down in the pancreas, we find, is also effective in some tumors that even don't have PI3K mutations. So we're very excited that this is a new intervention that's going to have a dramatic effect on patients' lives. And I'll stop there and glad to take any questions.
Yes, please, Professor. You know, that's really interesting. Being a medical doctor, I understand what you are saying, but at the same time, we have a bunch of people who are watching this presentation and asking very simple and stupid question. And the first one is...
I'm sure they aren't stupid. I'm sure they aren't stupid.
But nevertheless, I mean, the simple question is, if the lifestyle alone, is it enough just to avoid such diseases as cancer or diabetes, or it still has to be somehow corrected with the medicines, with the drugs?
Yeah, so I think that if we can impose, if we can change diets, I mean, first of all, let me say that historically, 100 years ago, the cancer rates in Europe and America were dramatically lower than they are today. And in fact, this is what got Otto Warburg interested in understanding what tumors were doing, because he was seeing during his lifetime a tripling of the rate of various cancers, particularly endometrial cancers, breast cancers, other cancers, and wanted to know what was going on. And he suspected at that time there was a dietary effect, because the increase in consumption of sugar in Europe and America had gone up 3 to 5-fold between 1880 and around 1920. And that was because growing sugarcane in the Caribbean suddenly made it very cheap, and sugar was being added to everything. So this massive increase in consumption of sugar was followed about 20 years later by a massive increase in the rates of a number of cancers. So yes, I would argue very strongly that if you can keep sugar low in the diet and other forms of rapid release carbohydrate low, thereby keeping insulin low, that you can reduce cancer rates even without drug intervention.
We got the conclusion. Sorry, we are very much short in time right now. That was extremely interesting and a very straightforward recommendation. I believe that our listeners and our visitors would really take care about their health. That's really pity for me because I love pasta. So I have some question if it's peak of insulin or just a general level of insulin and so on and so far. But definitely that's very straightforward recommendation, and definitely the way the agriculture industry developing last 30 years drives the human being to unhealthy eating at the end of the day, and we are actually suffering as the population, is the biological kind out of our wrong steps in the agriculture and in the food processing. Thank you very much. It was extremely interesting. И мое обращение к аудитории. Будьте здоровы.
I would like to address to the audience: be healthy, take care of your health. You
научное обоснование.
Listen to the detailed scientific explanation how to behave from the point of view of your nutrition, how to take care.
Мы – транспортно-логистический холдинг «Российские железные дороги». Мы развиваем транспортную инфраструктуру страны, строим новые станции, вокзалы и создаем новые возможности для вашего бизнеса. Лучшие скоростные и высокоскоростные поезда сделают ваше путешествие комфортным и безопасным. Мы – локомотив экономики. Сотни миллионов тонн грузов ежегодно. Развитие науки и социальной сферы – это наш вклад в благосостояние страны и ваша уверенность в завтрашнем дне.
Я новая Hyundai Creta. Hyundai.
Есть история фантастическая. Есть история сказочная. Есть страшная история. А есть история реальная. Юка всегда реальная история и диагностика автомобилей с пробегом. Юка – официальный сервис Hyundai. Смотрите историю и диагностику автомобиля и покупайте его онлайн.
If you want to stay ahead of the competition, you need the most advanced solutions to transform your comms performance. From media database to social influencers, distribution to monitoring, analytics to insights, Cision's cloud-based tools can help you communicate like never before.
Звонки ВКонтакте для работы. Больше никаких ограничений по времени и платных функций. Звонки ВКонтакте — это разговоры без конца с телефона и ноутбука.